Last video, we actually looked at the initial velocity. We are going to find our initial velocity based on the displacement in the x direction and the time of flight. So, how can we find our time of flight? This is how we're going to find our time of flight. We're going to use the y equation. So you see we have our initial velocity, we have our angle, we have time, we have our acceleration here, and we have time here again. And so if we can calculate this height, then we can use this equation to actually calculate the time. So let's walk through the theory a wee bit here. And we'll start with the equation. YF minus Y initial equals to V naught sine theta times T plus 1/2 AY T squared. So there are a couple of things that you want to look at. First thing is the angle. We're firing it at 0. This implies that the sine of 0 degrees is that the angle, well, is 0. So if this is 0, this further implies that V naught sine theta times T is 0. So this entire piece just goes away. So we end up with YF minus Y initial equals to 1/2 A sub Y times T squared. Since the ball is falling, there is a velocity, or there is an acceleration due to the Earth's gravitational field. And I say gravitational field, but due to the Earth's pull. And it is mass times gravity, and so it's actually a negative g. So acceleration in this particular case, or this implies that the acceleration in the y direction is, and you know what, I want to do this real quick. I want to erase this from being g to this being y. So the acceleration in the y direction is just going to equal to a negative g. Okay, so the negative sign indicates that it's going down, so we're accounting for the direction, and g is just 9.81. So this is a negative 9.81 meters per second squared near sea level. So let's just go ahead and put that into this equation. So negative 1/2 gt squared. So if we're going to solve for t using this equation, we would multiply both sides by a negative 2 over g. So I'm going to do a negative 2 over g right here. So a negative 2 over negative 2, or a negative 2 times a negative 1/2 is just going to be 1, and then g over g is going to be 1. So we end up with t squared equals to a negative 2 yf minus y initial all over g. This equation implies that t is just the square root of a negative 2 yf minus y initial, all divided by g. So we're going to use this to calculate the time of flight. But what do we need to know? We just need to know yf minus y initial. And we'll have the time of flight. So if I pull this up, primary thing that we're going to need is this. So time is here. We'll have our initial velocity calculated here. So we're going to use this particular equation, and we'll use our time of flight to calculate the initial velocity. Where t is equal to the square root of a negative 2 yf minus y initial over g. And that's going to be pretty much the end of calculating the initial velocity. This is all the theory we'll need. But we will extend on this for different angles. But this is where we need to begin, because we need to know the muzzle velocity. We need to know the initial velocity, or the launch velocity. They're all pretty much the same. I'm just giving you different terminologies.